Great. How much work is being done on this rock? So work, force times distance, with the force and distance parallel to each other. So we can draw this rock and we can say that there's a lifting force on that and gravitational force, and our lifting force has to just overcome the gravitational force. So, and then the distance, they're saying that goes from a height of 2.1 to 3 meters. So that means it's getting moved upward. And so that distance, not only is it parallel with the lifting force, but it's in the same direction. So we know that this work is causing an increase in energy. So we can plug some stuff in here. The force, again, it's the lifting force and it's just overcoming the force of gravity. So we can say mg, and the d is our change in height here. So we can say, just a little aside here, d is equal to what was the height at the end minus what is the height at the beginning, if that helps you out. And so we can say 3 minus 2.1 equals 0.9. So plus it's gone up 0.9. So we can go back to our little equation and we can kind of show that as an aside if we wish. And we can say the mass 4.7, g 9.8, and the distance 0.9. And you multiply those out and we end up with 41 joules. Now, one thing to point out is that had she gone the other way and lowered the rock from 3 meters down to the 2.1 meters, then we would say, oh, well, her lifting force, which she still has to, if she's just kind of lowering it slowly, she still has a lifting force that's basically equal to the gravitational force, slightly less as it goes down, and the distance would be in the opposite direction. So we would say that the work she did was a negative work. In other words, it was decreasing the potential energy of the rock, lowering it down. But in this case, the way it was laid out for us, was there work? Yes, indeed. There was force and distance parallel to each other. It turned out to be a positive work, in other words, an increase in energy. And the energy that we see increased is the potential energy. It was lifted to a higher spot, and so gravitational potential energy, to be a little more specific.